We will continue with our next presentation, which is held by Hans-Martin Heinkel. He is working at the company of Robert Bosch, and there he is into corporate research in the area of virtual prototyping. In the Z-level project, he leads the sub-project number 3, model development and usage. Today, he will speak about the credible simulation process. And Hans-Martin, yeah, let's go.
So, thanks a lot for the introduction. Also, a warm welcome from my side. In my presentation, I will give you an overview about the credible simulation process. But first, I want to thank Kim Steinkirchen, who did most of the work. Why the topic processes? 2 reasons. First, we need them. Second, most of our simulation engineers don't like it. And we want to change this. I want to start with the challenges before I will give an overview about the credible simulation process. Then I will go a little more in detail in the usage of the credible simulation process. I will finish the topic with the metadata and the tool support. I would first like to address the current trends and developments in the industry. So digitalization and virtualization in product development and therefore virtualized validation and release are on the rise. This means that more decisions are made on the basis of simulation results. We therefore need simulation processes. On one hand, that they can be integrated into company processes, and on the other hand, that this can be supported by collaborative development with partners. The key to success will be the efficient implementation and application of these processes. These aspects are particularly true in the area of the development and release of automated driving functions. This slide was already shown by Stefan in his talk. It represents a process hierarchy with a clear information structuring. In the first transition here, the concrete application situation is specified and the necessary information is transferred to the simulation-based engineering task. In the simulation-based engineering task, it is then determined how this task has to be processed and what the resulting subtask with their specific requirements are. In the area of automated driving functions, these are, for example, augmentation strategies. This process here is a focus of the public funding project VVM. The simulation task and goals are then passed to the credible simulation process itself. From the CSP, requirements then can be passed on to the models which have to be created. This process hierarchy is a part of the big picture of the Z-level project. The processes are structured in such a way that they can be integrated in the company-specific process framework. And very important, we need all this information for the proof and documentation of the quality for a decision based on a simulation result. In the next slide, I will show a little more details of the CSP. Focus of the CSP is traceability and comprehensibility. This is supported by the clear information structuring. So which information is needed where and what are the input and outputs of this process element. And it's also a documentation schema. And it's further a framework for methods. So it is specified in which process elements the specific methods, for example, verification, has to be processed, what are the necessary inputs, what are the outputs. So these processes supports and shows more for documentation and for traceability. It's not focusing on all the iterations, but it's possible here, and we can show also afterwards that it's easily possible to integrate here iterations. And the iterations results are stored in these dedicated places. We are currently applying the CSP in the simulation use cases in our GitHub. We have very positive feedback here about the benefits of the clear information structuring and provisioning you can see here. So the people knows if they are looking for requirements, even in what phase of the project, it's clear where they can find the necessary information. And that's very important, especially with our very heterogeneous and spread working teams. This is the view how we use the CSP within the Z-level project. Now, the very important question. What does this kind of collaboration between partners look like in a real industrial project? For an example, partner A wants to check with a simulation if a certain functionality can be realized with a camera of partner B. He would like to use a camera model of partner B for this purpose. There is corresponding requirements for the model, interfaces, map effects, and test criteria are then transferred to the partner B, and the model is handed over to partner A again. Important here is the coordination process of the partners. Currently, we perform industry workshops for the proof of concept of this cooperation process. I would like to go into more detail here about this cooperation process. So a cooperation process is always composed of an agreement process and the actual development process. In the case of simulation aspects, this agreement process is usually covered by the higher level product development agreement. Often, of course, the simulation specific aspects are not fully clarified in this agreement process. So focus of the agreement process should be clarification and definition of the technical and contractual bounding condition for the simulation. That means time frame, costs, involved persons, updates, support, intellectual property rights, and so on. Now to the point of traceability and proof of quality. The consistency of process and data is crucial here. On the left side, we see the process framework with a credible simulation process. There we introduced a consistent XML data schema. The relevant information sources are glued together in this schema. This is where the name glue particle comes from. What does the glue particle approach means? It supports the consistency of process structure and data structure. And this is a prerequisite for tool-supported traceability. Now, documentation and metadata. There are typically several layers of detailing in the documentation. Basis is the information created in the credible simulation or modeling process. The documentation and records should be derived from it, single source of information. So we need two kinds of traceability. One is a traceability along the credible simulation or modeling process. The other is a traceability along the documentation. And according to the XML glue particle schema I showed in the slide before, a consistent XML schema for simulation resource metadata was created for this purpose. This is how we can support traceability and maintainability. We already have a first tool support. For this, I will show a little more on the next slide. Here, for example, we are in the phase implementation, and here in the substep implement the simulation models. You can see here the already existing elements, and you can select, for example, the pedestrian model with the OC interface, and you can see here the attributes, and you can also show, for example, here the source code itself. Stephen will go in this talk a little more in details. So now to the conclusion. We need the use of simulation for the development and the release of automated driving functions. With a credible simulation process, we have a process framework that supports the necessary traceability of simulation tasks that can be integrated into company processes that supports collaborative development with partners. Status is the credible simulation process will be public available beginning of May, the modeling process end of May. The according XML data structures are already publicly available. You can use that link here. And now I'm open to questions.